Hello everybody. Today we are here on my messy kitchen table with a project that we're working on to get that sign right there working and blinking. This is a legitimate crosswalk sign with the hand and the walking man thing that you can see there. That was actually used in an urban environment. My daughter got this when we were on vacation, and we went through Indianapolis this summer. We stopped at a antiques and whatnot shop, that sells trinkets and various miscellaneous odd items. And she saw this and was like, "Is that like a real street sign?" Yeah, they were actually used apparently in Indianapolis, and then they changed a lot of them out, it sounds like, and put the ones with a countdown for the crosswalk, so you know how much time you got left and all that kind of stuff. But everything in the place was half off, and this was only $40 originally, like 42 bucks, something like that. So my daughter really, really wanted it, and she kind of tossed the idea around while we were looking at other stuff. She ended up finding other things that she wanted and decided to go ahead and take a chance on this, because we honestly didn't know if it worked or not. It just had 3 wires sticking out of it, no plug or anything. They don't come with plugs. They connect into a control unit that controls and times it so that it works with your traffic lights. So we didn't know if it worked or not. We decided, at 21 bucks, let's take a chance. So she went ahead and did that. We brought it back home. I looked up the specs on it, figured out the wiring on it, and we tried it, and it works. It is an LED sign, so it takes very little energy, and thus our idea was kind of started. Now, this has got a shut off or a safety circuit in it so that I can't plug both the man and the hand in and have them both illuminated at the same time. It's designed so that you can't do that, so you don't confuse people, I suppose, when they're out trying to either figure out whether they got to cross or not. So if you apply the white wire back here is the common, and then you got your orange and your blue for your, whichever is which. I think the blue is for the hand and the orange is for the man, or something, or the opposite. I'm not real sure. But it's designed so that if you apply voltage to both at the same time, only one comes on. I think it's like the hand or something as a stop precaution kind of thing, so that you don't confuse people. So if they would have both come on at the same time, we might have just left it at that. I might have just stuck an old extension cord end on it, wired it in, and called it good. But we couldn't. So my daughter didn't want to just have one side plugged in and working, because people would come over and look like, okay, so it never does anything. It's kind of boring. And we agreed. So she wanted to know, was there a way to make this function then? So an idea was born. How about using an Arduino as a timing circuit to control a couple of relays that can make this work? This doesn't work off of low voltage. It works off of 110 volt house current, house voltage. So I can't just run that through the Arduino, which only operates on like 5 volts DC. So we had to have a way of allowing the Arduino, which acts as a timing circuit, to control this, and that's when I decided, how about a relay? In automotives, you use relays all the time to allow the small little dials and switches on your dashboard to control much higher current draw devices, such as your headlights, your fuel pump and things like that. So let me show you what we did. This is all wired in just haphazardly. So disclaimer, unless you know how to work with electricity, unless you have experience, don't go trying to replicate this. I'm working with 110 volt AC here, and if you don't know what you're doing, it will kill you. If you touch the wrong spots in the wrong times or whatever, don't do it. Just don't do it. Unless you are experienced, just look and enjoy. Don't try to make it happen yourself. So here's what we're doing. Okay, my sign here has to get AC from the wall. So what I'm doing is using the Arduino, which I only need 3 connections off of, a ground, and I'm using outputs 13 and 12 and alternating, providing a voltage to, or a signal to each one, a voltage. It will provide an output voltage for 15 seconds, and I think I'm going to change it to 20 because I don't think 15 is long enough. But what I originally started out doing is connecting this to some old school relays. The Arduino what a relay does is allow you to provide a small input voltage, such as the 5 volts that the Arduino uses, to operate a physical switch that you can then run your high voltage or high current through. This switch, what happens is when you apply a small voltage over here, there's an electromagnet in here that pulls a contact down so that the circuit is complete, so your voltage can flow through here and on up to your sign or whatever you've got connected to it. It's really ingenious, and they last a very long time generally. The only problem with this is a relay, your turn signal in your car that goes click, 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 that's a relay. So every time voltage was applied to switch this from one side of the sign to the other, this would click. Now it's only happening every 15 or 20 seconds, but you listen to that going 15 or 20 seconds, a click every 15 or 20 seconds, on and on and on. That's going to get really annoying. No matter what kind of a project case you put this in and how much you work to sound deaden it, you're still going to be able to hear a little bit of that. So, but it worked. This worked beautifully to control that. So what I ended up doing is going with a device that's all electronic. It has no moving parts in it. This is a solid state relay. Now the difference is this relay will let me pull 10 amps of current at 110 volts AC. For comparison, a 1500 watt hairdryer has a maximum current pull of 12.5 amps. This only lets you pull 2 amps through. It doesn't use moving parts. It uses a small trigger voltage to electronically control the gate in a resistor to either allow the flow of electricity or not. So it's not quite the same. This would be the same kind of thing that you would find in an amplifier or circuit or something like that. It produces a lot of heat if it's under a lot of current draw, and you can overrun the current load on this so that even if you don't have a trigger voltage applied, you can have enough current going into this and trying to be drawn through it that can actually activate anyway, and it'll usually burn this out in the process because your current draw is too big. Now, this only needs this can only pass 2 amps of current. Is it enough? Yes, the sign has specs on it where one side pulls 4.8 watts of electrical consumption and the other 5.3 watts. Now if you use Ohm's law, watts divided by volts equals amps. 5.3 watts divided by we'll say 115 volts because your current can vary between 110 and 120, your voltage. We'll say 115 for a middle of the road. You get like 0.046. We're just going to round off and say 0.05 amps. 5/100ths of an amp. That's 1/20th of an amp, and these are rated for 40 times more than that. These don't even get warm, not the slightest bit, so that's absolutely perfect, and they are dead silent. So, and the code to control this I'll flash up for you here right now. Very super simple. All I'm doing is alternating voltage to this or this. That's it. When this no longer has voltage, this does. It turns this off, turns this on, turns this off, turns this on, and just keeps going back and forth forever. So what we're going to do is plug in the AC current, which is passing voltage through my relays here over to the sign. Now, for right now, I'm just going to plug in this little battery bank, and it'll do a startup on the Arduino. And now the Arduino is applying a voltage to here. All I need is a ground and my trigger voltage from the Arduino. So you only got 3 wires, and it'll switch every 15 seconds back and forth. It'll turn this on or off. If I look at the relays here, you'll see it should turn, flip to in just a second to the other one. See, that one's on now. See the light, and this one's off. So we'll wait a few seconds and let you see that again. See? And now that goes from the hand over to the man every 15 seconds and back and forth. And I'm going to change, like I said, that to 20 seconds because I think 15 seconds in a display is just too short. And I may even pass that up to 30, but I'm just going to start with 20 right now. If I want to change it later, all I've got to do is plug my USB cable into my computer and upload my new code. Works absolutely beautifully though, doesn't it? Now, what are my next steps? My next steps would be to find a project box to mount this all in and wire it up a lot prettier. I've just got a little, the little white block with your connectors going back and forth to everything right now is just a proof of concept, and the concept worked beautifully. But I don't want to have to plug in a battery bank or USB, so my next thing is I've got a power supply that I'm going to tap into the AC voltage on this side, and then I can just plug this side into where a 9-volt battery would normally plug in on the Arduino. So I'll do that, and then we'll come back and test it, because then all I've got to do is plug the one cord into the wall, and then everything should be powered, and I shouldn't have to have an external battery bank on USB. If this works like it's supposed to, like it should, it's a pretty basic, simple thing, then I will take a project box, and I bought one, but it's way too big. This thing is gigantic. It sounded good, but I bought one a lot smaller. It's on the way. It'll be here in a couple of days, and I'll show you the video of that. I'll mount all the stuff inside the project box, run my electrical cord through it, make it, knot it so that it can't come back out. And I have a cord that I'm going to run, it'll go from the wall to the project box, and then from the project box up to the sign, I need 3 conductors. So what I found in the store was this designer fabric covered 3-conductor 16 gauge extension cord. And we don't need the 16 gauge because, as we've just determined, we're pulling 0.05 amps of current. But this has a really cool texture. It's a braided cloth on the outside, and I think this would be really nice going from the project box up to the wall, behind, to the sign. I'll wire it into the sign back behind and make it look all nice and neat, and put a hanger on the back of the sign so we can hang it on the wall and use it as a display piece for my daughter. So all she'll have to do is go plug it in and unplug it when she's done. I could build a switch into it or something like that, but I'm not going to do that. I don't think I want to do that. I have smart switches that I buy from Wyze, W-Y-Z-E, that I can control with my phone. So I think I'll just end up getting one of those. And if she wants to turn it on and off, she can use her phone to turn it on and off too. So, or we could put it on a timer to start at a certain time of the day and turn off when everybody goes to bed or whatever. So let me get this wired in and see if this works without having to have our battery bank. And then we're one step closer to having this project wrapped up. Okay, here comes the moment of truth. Let's plug her in and see what happens. Ooh, it came to life. There it goes. Okay, so I have this wired in to my extension cord piece here, plugged into my Arduino. I have my USB disconnected, the cable sitting over there, so it's just being powered through one plug going into the wall now. And again, if you've never messed with electricity, don't be trying to do any of this, especially like I have this laid out on the table here. I have live 110 volts AC coming off of this into the, relatively close space connections there. And if I were to touch it out on the bottom of there, I would get shocked and possibly die. Current also going through these into the relays here. Same thing. Not something you want to mess around with. Now, the relays don't get hot. If I look on the back of these, they do have aluminum backings that are designed to bolt to a heat sink to help dissipate heat under high current loads. These things don't generate any heat. They are cold. And I've run them for probably 4 or 5 hours with the original relay setup with the noisy ones in there, and no problem at all. They didn't generate the tiniest bit of heat because there's not enough current draw. So my next step would be then to get my project box and wire all this in properly without my, intermediate stuff here. Wire it in all properly and button it up. And then I've got a nice, I'm going to try to make it as professional looking as possible. And I've got a nice sign that my daughter can have for a very long time and be proud of in her purchase. Now, I did spend more on the components than she spent on the sign. I think these were about $8 for 2. The Arduino I got from my daughter who just moved up to Michigan Tech. Go Huskies! She's her first year of college, and she has several Arduinos that she had here because she's going in for robotics and has stuff like that. So she just gave me one of those. I think this ran me about $8 or so as well. The extension cord I already had, and I think I'm going to go ahead and use this for my input. My project box was about $8.50, and the cord here was $12. I got a 12-foot one because I wanted a nice long cord to go from my project box up to that. And that's it. Just one cord plugs in and that'll run the whole system. Now the only thing is I could have built a switch into this or somewhere where I could go to the project box and turn it on and off or something like that. But I don't think I'm going to bother. I have smart switches from Wyze, W-Y-Z-E, and I think I'll just plug that into the wall and then plug this into the smart switch. And there's a button on the side of it that you can do it manually. Just touch the button and it'll turn on and off. So switch built in. Or you can control it through your phone, through any location. It connects to Wi-Fi, so you can connect it from anywhere. You can have it started and running before you even get home. So I think that's what I'm going to end up doing. I just got to wait for my new project box because that thing, the original one that I got to try, is just so gigantic. I don't want it to look like I've got some, gigantic thing down there. So, anywho, I'll show you what that looks like when I get everything mounted inside the project box, and then what it looks like mounted up on the wall. So it'll be a bit, and I'll get back to you. All right, guys, it is a different day, and we're back at it. My new project box came in. This one is a lot smaller. I mean, it looks big, but here's my hand compared to it. It's not that big. This is a little bit bigger than a power supply that you might find for a laptop or something like that. So this is a lot more acceptable. The other one was massive compared to this. I consider this okay. I've made a little bit of progress. I've wired in the new extension cord piece that we got to go from this up to our sign. And it looks beautiful. I'll show you the back of that. Then I'm going to take all my stuff and start fitting it into the project case and make it so that the cord can extend out of that and look nice and healthy. I don't have any grommets. I think I'm just going to do a small hole so it can fit in snugly, and I'll put a heat shrink wrap around that section so it doesn't fray or anything like that. I don't expect it to, but I think that'll be fine for what we're doing here. So let me show you the back of the sign. Here is the back of the sign, and when I told you guys about the ratings on there, 4 watts and 5.3 watts. The man draws 4.3 watts, and the hand draws 4.8, so a very low current draw. This is the model number of that thing if you ever wonder about it. But I made all this nice and tidy with multiple layers of heat shrink tubing going down through here so it would never come apart. I attached it midpoint here with this like a metallic pinch clamp, and then I used a rubber pinch clamp here so it would give it a little bit of flex. So instead of fraying this cord against the metal or anything like that, or ripping this out of the back, it just wiggled a little bit. And pro tip, these you can get at a sporting goods store. They're designed, if you've got a softball player in the house like I do, these are designed to hold the softball mask on the front of a helmet. And you get them for, you know, $3 or so for a package of them. So really handy to have. Just a short screw to attach into there. So now that's good. And I've got a nice long cord here that I can run into my project box and start piling that stuff in it. So let's get started. Alrighty, it is a bit messy. I left some of the wires much longer than I should have, like all of this right here, to make sure it was easier to work with. I got these hot glued in place. I've got my you know, relay that goes out actually through here, so this comes in and loops back over to here, and then actually from the AC it comes into here and then loops back over to there to go out to the sign. My power supply I have mounted on the side down there, out of the way. My Arduino I was hoping to mount setting down in there, but this is fine. It's just kind of flopping in there, but it's not going to go anywhere. And if I need to, I can pull this out and reprogram it that way instead. So I'm going to leave it like that. And I think I might, I don't know, later I might, if it gets to be a problem, I'll get a piece of foam or something and sit down in here to push it down in place. I don't think I'll really need it, so that's how it looks. It's not pretty, like I said, but if I plug the power in, I'll see the, you know, lights come on, the test lights on the Arduino, and then I have my sign. I reset it to 20 seconds. So play the Jeopardy theme song in your head if you need to. And we'll go from there. After this, after I button this up, I'm going to go get me some tacos because I'm hungry. And there it goes. There we have it. So let me finish buttoning this up and I'll show you the finished product actually. All right, here is the finished product laid out on my counter. I've got the project box holding all the electronics, cord about 4.5 feet long to go to the wall, and then from here to here, that's probably 10 foot right there. So you can, there's way more than we needed, but that's fine. I wanted to be able to like sit this in the middle of the wall and an outlet be way over here or something, so that's fine. This is held down so it's not going to move, and I just took these, for right now anyways, I may change this to like a solid bar with notches in the middle, like a picture frame. But basically all I did was solder a couple of round connectors to some spare wire, and I've got that stress between there, and I can hang this on a nail on the wall. So really easy. It looks good, except for this. That's the only thing that doesn't look as professional, but if you hang it up on the wall behind, you're not going to notice it anyway. So let's go hang it up and see what it looks like. There we have the final result. When you are straight on and the room is pretty dark right now, that is bright. I tell you what, when I'm sitting down on the couch, I've got a couch right here. When you're down on that end and your viewing angle is at a side glance, it's not so bad. When I sit down in the spot where my daughter usually sits, it's not too bad. It is pretty bright though, so we may have to move that down to that end over there so you've got more of a sideways viewing angle. It'll illuminate the room, but it won't shine right in your eyes. These are designed to be used during the daytime, so that you can see them from across the street to let you know whether you can walk or not. So it does make sense that they would be pretty bright. So very, very pleased with the results. It looks fantastic. It works beautifully. And I have this set up on a Wise smart plug, so I can start it and stop it from anywhere with a phone. So super easy to do. You can't be happier with the results.